Our objective for this lesson is to simplify ratios, such as in the examples given on this page. Let's start by trying to simplify the ratio 4 to 6. We'll do this in picture form first. So 4 to 6 just means that for 4 of one object, so blue circles in this example, you have 6 of another, so red circles in this example. Well, we can split this into 2 equal groups. So now let's look at the top group. We've got 2 blue and 3 red, which is exactly the same as the bottom group. So the ratio must be the same as 2 to 3. We've simplified it. We've made the numbers smaller. Now, how can we do this without using a picture? Well, if we look for a factor of both 4 and 6, we can divide through by this. So 4 and 6, they share the factor 2. Divide both sides by that, which gives us the ratio 2 to 3, just like in our picture example. Let's try a harder example with bigger numbers now. We're going to write the ratio 16 to 40 in its simplest form. So we start off by looking for a factor of both 16 and 40. Well, there are 3 to choose from in this. They're both divisible by 2, 4 or 8. For this example, let's go with the largest factor. We will see why soon. So, dividing both sides by 8 gives us 2 and 5, so our answer is 2 to 5. Now what would have happened if we had divided by a different factor? Let's go with 4 this time. Dividing both sides by 4 gives us 4 to 10. Now if we check 4 and 10, well, they can both be divided by 2. So let's divide it again. We get the same answer as before, 2 to 5. So it doesn't matter which factor you start with, it will get you there in the end. But if you choose the highest common factor, which was 8 in this example, you'll get there in one go. If you choose a lower factor, it will just take more steps, but you will still get the same answer in the end. And the exact same method works if it's a 3-part ratio. So we're going to write the ratio 30 to 60 to 45 in its simplest form. So we're going to find a factor of all 3 of these. 15, that goes into all of them, and we will divide all 3 numbers down by 15, which gives us the final ratio of 2 to 4 to 3. Now let's just check, can we divide 2, 4 and 3 by anything? Other than 1, there's no factor that they share, so that must be our final answer. Pause the video and have a go at these practice questions. The answers will appear shortly. Sometimes you'll be asked to write a ratio in the form 1 to n. N can be any number, it doesn't have to be a whole number. So in this example, we're going to write the ratio 5 to 12 in the form 1 to n. Well, that left-hand side, we need to change that into 1. So to change 5 into a 1, we're going to divide it through by 5. But to keep the ratio the same, I have to make sure we do the same to both sides. So 5 and 12, divide them both by 5, we get 1 to 2.4. That is our new ratio. Sometimes you might be asked to do it the other way round and write in the form n to 1. It's the same idea. This time we need to change that 12 on the right hand side into 1. So we're going to divide both sides through by 12, which will give us a ratio of 0.42 to 1. Now the reason for doing this, simplifying a ratio into the form 1 to n, is it often makes them a lot easier to compare. So let's look at this example here. Katerina and Jasmine are making fruit drinks. Katerina uses 100 millilitres of squash and 350 millilitres of water, while Jasmine uses 80 millilitres of squash and 310 millilitres of water. We want to know who has made the strongest drink. Now, at the moment, it is very difficult to tell using those numbers. So if we put both of those drinks into ratios of squash to water, and then simplify them to the form 1 to n, we should be able to compare them more easily. So, Katerina's ratio is 100 to 350. Jasmine's is 80 to 310. By dividing these through by 100 in Katerina's case and 80 in Jasmine's case, we can get ratios in the form of 1 to n. So now we can really easily compare these. We can see that Katerina, for every unit of squash she uses 3.5 units of water, whereas Jasmine, for every unit of squash, she uses 3.88 units of water. So that's more water per squash, hence Katerina must have the strongest drink. Pause the video and have a go at these practice questions. The answers will appear at the end of the video.